In this video, a bowling ball rolls across the floor toward a student with a broom. Using only the broom, the student will make the bowling ball move in a perfect circle at constant speed. He does this by applying the exact force needed to continually change the direction of the bowling ball. This is not easy to do. If he hits the ball a little too hard or too softly, the ball will move in an oval-shaped path and not a circle. Notice the force he applies always points in the same direction. His force always points towards the center of the circle. In this presentation, you will learn what is required to make an object move with constant speed in a circle. You will also learn about the direction of the velocity of the object as it moves with a constant speed in a circular path. Understanding the physics of uniform circular motion is important because it's the first step towards understanding why the moon orbits around the Earth and the 8 planets orbit around the sun. Isaac Newton was the first person to realize that the same invisible force that curves a ball to the ground when it is thrown horizontally off a mountain curves the moon around the Earth and the planets around the sun. The invisible force of gravity that curves the Earth around the sun is directed towards the center of its orbital path and is an example of a centripetal force. In his famous book, The Principia, Newton proposed that if air resistance weren't present, an extremely powerful cannon could theoretically give a cannonball enough speed to orbit the Earth. Take a look at these motorcyclists. You can tell they are traveling at a tremendous speed. The greater the speed, the larger the center-directed or centripetal force needed to move in a circle. The centripetal force comes from the friction between the tires and the road. They lean in this way to counteract the torque produced by the centripetal force. Don't worry about understanding torque right now. When an object moves with constant speed in a circle, the speed is constant, but the velocity is changing because the direction is always changing. The force on the object is centripetal, or towards the center, and the velocity is tangential, or tangent to the circle in the direction of the motion. When the centripetal force on an object is removed, the object moves, and it moves in a straight line tangent to the circle. The centripetal force must always be perpendicular to the velocity for an object to move in a circle. An object moves counterclockwise. Let's look at the direction of the centripetal force and velocity of the object at 4 positions. The centripetal force at each of these positions is directed towards the center of the circle. The velocity of the object at each position is tangent to the circle in the counterclockwise direction. Let's review a key point. In order for an object to move at constant speed in a circle, an outside force must constantly turn the object towards the center of the circle. This force is called a centripetal force. Whenever we draw the centripetal force and the velocity, we always draw the centripetal force first, then draw the velocity perpendicular to that force. Can you predict the direction of the centripetal force? Will the velocity vector go up or down? Once again, the force is centripetal or center-directed, and the velocity is tangential. These two vectors are perpendicular to each other. This ball is attached to a string and moving clockwise. At what point, A, B, or C, would the string have to be released for the ball to hit the target? The string holding the ball should be released when the ball reaches point B. At that point, the ball will move tangent to the circle and hit the target. A car is making a left-hand turn and hits a patch of ice at point P. The ice causes the car to lose its centripetal force. In which direction will the car move when it hits the ice? Since the car is moving in a circular path, when it hits the ice, it will move tangent to the circle towards point B. The centripetal force needed for an object to move in a circle is determined by the object's velocity. The greater the velocity, the greater the force required to move at constant speed in a circle. In this presentation, you learned that in order for an object to move at constant speed in a circle, it needs a centripetal force. A centripetal force is a force directed towards the center of the circular path that changes only the direction of the object. The centripetal force is always perpendicular to the velocity of the object. While the speed of the object is constant, the velocity of the object always changes due to a change in direction. This is the end of my presentation on uniform circular motion.